Alrighty, guys, we're going to add to our notebooks again. So if we open up to our new tab now about solving equations, today we're going to talk about solving two-step equations. So what that means is in 2 steps, I should be done. Like I should have to do a thing and then another thing, and then x should be solved for. We're going to do this on 17 and 18. Okay, so if we turn to page 17 and 18, we're actually going to leave page 18 blank. We're going to take some notes together on there. The next page that you have in your packet should look like this, and maybe look like that. And so if you're looking at this side, you actually want the paper tall, and we're going to fold the short edge down until we can see this at the bottom here, two-step equations and inequalities. Now, you maybe just heard me say a word, inequality, that you maybe remember from last year, but we have not talked about yet. If you remember it, that's great, and you can kind of solve some of these, but if you don't, that's okay. We don't need to solve them yet. We will talk about them all together later in this class, okay? So I made a little cut up the middle so that we have 2 flaps like this. And I'm going to tape this on page 17 sideways, which is kind of annoying, but it's all right, we can make do. So I'm going to tape it in like that, just because it kind of doesn't fit the other way. Okay, so I actually want to start on page 18, and we're going to write some things out, try some examples, and then we'll try a few more on page 17. So today, like I said, we are solving two-step equations. So just as a reminder, whenever we are solving, we need to think about reverse order of operations, and I think about sad meat, reverse order of operations. So that just means I'm looking for addition, subtraction first, then multiplication, division, then exponents, then low-key parentheses. Okay, so that's the order we want to go in rather than normal order. The other thing that we want to be thinking about is, how do I undo that? It's kind of like a term or a question saying, what is the inverse operation? So I always ask, how do I undo subtraction? I'm really asking, what is the inverse of subtraction? But I just like undo better. And then third, we're always trying to just get x alone. So is x alone yet? If x is alone, then you know you're done. If it's not, you gotta keep going. So again, I always feel like it's good to just show with examples. So let's just dive right in. Examples. So the first one I want to try with you, let's write this out. We have 5 plus 4x equals 33. Okay. So like we were doing the other day with our one-step equations, I always first like to start by putting in a line, a vertical line, to show the 2 sides of my equation. So I put that vertical line in where I see the equal sign, so that I have my left side and my right side. Now on the right side, it's just a 33. There's not much to do over there, so I don't need to worry about it too much. On the left-hand side though, that is where my variable is, that is where x is, and I'm trying to get him alone. And he is not alone because you have this 4 attached to him, and you have this plus 5 attached to it. Okay, so if we're thinking about reverse order of operations, I'm first looking for a number being added or subtracted. So add or subtract, we want to get rid of that first. And there is a number being added or subtracted here, and that's the 5. That 5 is being added to the variable term. And so I want to get rid of that first. It's a positive 5, so to undo a positive 5, I would have to add a negative 5 or subtract 5. If I do it on one side, I have to do it on the other. And then I can simplify. Okay, so on this side, 5 and a negative 5 is 0, and 0 plus 4x is just 4x. I bring down my equal sign. And over here I can simplify as well. 33 minus 5 is 28. Okay. We got rid of the addition and subtraction. There's none of that left. So now, moving on to our sad meat, I would think about, is there multiplication or division? And usually multiplication is like low-key multiplication, so a number smashed up on a letter, or usually division is like a fraction bar, okay? If there's one of those things, you got to get rid of it. Or if there is a fraction, okay? So this 4 is being multiplied to that x. So to undo multiplication, I would divide. So I divide each side by 4. So I just do my division bar. And 4 divided by 4, I can do. 4 divided by 4 is 1. And 1x, I can just write as x. I bring down my equal sign. Over here, I can simplify. 28 divided by 4 is 7. And then I ask myself, are there exponents? Are there low-key parentheses? No, 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 because x is alone. So is x alone? Yes. And so that is our answer. And remember, we can always check our answer by plugging it back in. So if I put in the 7 for x right here, then I would follow order of operations. And 7 times 4 is 28, plus 5 is 33. So I know it works out. Now that's a very straightforward way of solving. Another way that I like to solve is called the onion method. And what I mean by the onion method is with an onion, you have layers and layers and layers of disgusting onion. I actually love onions, but yuck if you're eating it on its own. So the onion method, I still want to draw in my sides, but I start by circling my variable. I'm going to create an onion where my variable is. So my variable right here, I'm going to circle it. And then I want to think about what's happening to x. So the first thing, if I knew how much x was, the first thing I would do to it is times by this -2. So that's what I circle up next. And I kind of write in there times -2. Then after that, I would add to it this positive 29. And so now I circle this up again. I have an onion, and I'm really adding a positive 29 here. Okay, so that's what's happening to x. Let's say that x was 5. I do 5 times this -2, and then I add 29 to it. That's how I would get my answer if I knew it. So now, once I have it all circled up, I peel off the onion. So I unpeel the onion. So you have to start in your outer loop. And in the outer loop, I see plus 29. So I do the opposite of that, minus 29. Whatever I do on one side, I have to do on the other. And then I simplify. So 29 and -29 is 0. And so then I can bring down the next layer of my onion. So we're at -2x, circled, circled, times by -2. Bring down my equal sign. And then over here, 13 minus 29 is going to be -17. Ooh. Right? No, 16. I got worried there for a second. But I shouldn't be. And the reason I was getting worried is because I know what's going to happen next, and you aren't going to like it. But it actually would be fine. We'll talk about it. I go back over to x. The next layer of my onion has in it times -2. So the opposite of times -2 is divide. So I divide -2 on both sides. So that gets rid of that layer of the onion. And now all I have left in my onion is just x, so that's alone. And then on this side, negative 16 divided by negative 2, I can simplify that. It's 8. X is alone. I think the answer is 8. And so just going back to when I thought this was negative 17, and I was like, ooh, it's okay if you're left with a fraction answer. It would have been okay if negative 17 over 2 was your answer. That would have been fine. I didn't do that because I know you guys like to just have a whole answer as your final answer, but it's okay if that happens. Now, the last method I want to show you is like the cover-up method. So I'm going to try to squeeze that in here. So that is the onion method. And then we got one more, the cover-up method. So let's say we have x over 2 minus 5 equals 25. And this is going to be the cover-up method. So what I mean by that is still put in my vertical bar where I have my equal sign. And when I say cover-up method, I want to find x, and anything that's directly on it, I cover up. So now I'm really just looking at my variable minus 5. And so to get the variable alone, I need to get rid of minus 5. So I add 5 both sides. And negative 5, positive 5 is 0. So I'm left with whatever I covered up, which is x over 2. On this side, I bring down my equals. 25 plus 5 is 30. And since I covered it up, I need to see it now. And we're just in a one-step equation situation. I have x divided by 2. I don't want divide by. I want the opposite of that. So I times 2 on both sides. And so 2 divided by 2 is 1. So 1x equals, on this side, 30 times 2 is 60. And if we want to plug it back in to make sure that we're right, because x is alone now, I could do 60 divided by 2, which is 30, minus 5, which is 25, and so it all works out. Alrighty, so if we turn to our next page, 17, I'm actually going to turn my notebook sideways so that we can see this. We can do this one here because we should hopefully feel kind of good about solving two-step equations now. We don't need to do this flap here because this is inequalities. So if we open up this flap here and try a few, we're going to solve the equations below. So I find my equals and I draw my two sides. My variable is on the left-hand side and I want to get it alone. Okay, so I first look for addition and subtraction and I have plus 9. So I'm going to do the opposite of that on both sides. And then I write my new equation. So 4b plus 9 minus 9 is going to be 4b plus 0. So just 4b. On this side, negative 3 minus 9 is negative 12. And now b is not alone. The thing that's happening to b is it's being multiplied by 4. So to undo this low-key multiplication of 4, I divide 4 on both sides. And 4 divided by 4 is 1b. And on this side, negative 12 divided by 4 is negative 3. So b is alone. We think that's our answer. We can check it by plugging it back into the original. So 4 times negative 3 plus 9. Is that going to equal negative 3? So to know if it'll equal negative 3, I have to simplify this side and follow order of operations. So negative 12 plus 9. Yeah, that is negative 3. So yes, it works out. Okay. Another one to try here. If I draw in my sides where I have an equal sign, I need to find my variable. And this time, my variable is on the right-hand side, but it doesn't change anything that I do. It's still solved the same way. So if you think about the onion, because I really like the onion, I circle my variable. And then the thing that's happening to x first is I would times negative 8. And then the thing I would do to it after that is subtract 11. So if I peel back the onion, the first thing I need to get rid of is this first layer, which is minus 11. So I add 11 on both sides. So 13 and 11 is 24. I bring down my equal sign. This first layer of the onion is gone because minus 11 plus 11 is 0. And then I have negative 8 smashed up against my x, which is low-key times negative 8. So to get rid of this next layer of the onion, this times by negative 8 thing, I need to divide by negative 8 on both sides. And 24 divided by negative 8 is negative 3. I bring down my equal sign, and the negative 8 being multiplied and divided is 1 x, and so x is alone, and I'm done. And I kind of took up all the space to check my work, so I'm going to skip that this time. Oops. Alrighty, number 3. I find my equal sign and I draw in my sides. The last method I can talk about is the cover-up method. I find my variable and whatever is on it, I cover up. Okay, so now my variable is right here, and it's just a one-step equation. I have something plus 11. And so to get rid of the plus 11, I subtract it on both sides of my bar. And a positive 11, negative 11 is 0, so all I have left is what I covered up, which is w over 3. I bring down my equal sign, and 29 minus 11 is 18. And now I just have a one-step equation like we were talking about the other day. And this is something divided by 3. So to get rid of divide by 3, I need to times 3 on both sides. Because 3 divided by 3 is 1. That means w is alone. And over here, 18 times 3, we got 54. And then we could plug it back in to check. And so to check my work, I'd have 54 divided by 3 plus 11. Is that 29? So 54 divided by 3, like 3 goes into 5 one time with 2 left over, and 3 goes into 24 8 times, and 18 plus 11 is 29. So yes, it all works out. Okay, last but not least, I draw in my vertical bar where I see my equal sign. I find my variable, which is g right here. And this is one where there are kind of low-key parentheses, because if you have a big divide bar, this is kind of low-key parentheses, and that has to happen last. So the first thing that I really need to get rid of here is this whole divide by 3. Like the big divide by 3 needs to go away, which feels very backwards because we really want to get rid of addition or subtraction first. But I can't get rid of that plus 9 because it's trapped with the bar as well. So we times 3, both sides. Now, if I think about the onion method here, that really works because g, and then I would add 9, and then I would divide 3. And so you can see that divide 3 is in the outer loop. So I need to get rid of divide 3 first. So that's going to be 1, and you're going to be left with g plus 9 equals 24. And then we have g plus 9. So to undo plus 9, I subtract it on both sides. And g is going to be equal to 15. And we can always check to make sure that we're right. So if I plug that back into the original, we'd have 15 plus 9 divided by 3. Is that 8? So I'd have to do 15 plus 9, which is 24, divided by 3, which is 8. So it all works out. All right, hopefully you guys kind of remember that, and hopefully that was okay to show you 3 different ways. You don't have to do it all the different ways. You just pick the way that you like and solve. So good luck.